Yo, what is up, guys? Welcome back. Another episode, another day, some more problems. Probably gonna have a look at some more bit manipulation problems today. One second. But yeah, let's kind of jump straight into it. Let's kind of take a look at our problem of the day. So the same one yesterday. I think we're just going to take a look at finish off Leetcodin's bit manipulation over here. Believe we did this one, reversing bits, missing number. I think we looked at this one already. Let's take a look at reverse bits, and then we'll take a look at some of these other ones. Reverse bits. Oh, we haven't even solved this one. Anyway, reverse bits of a given 32 bits unsigned integer. What is going on here? Okay, so note that some language such as Java, there's no unsigned integer type. In this case, both input and output will be given as a signed integer type. They should not affect your implementation, as the integer's internal binary representation is the same, whether it's signed or unsigned. In Java, for an example 2 below, okay, so we're given this 432.61596, and well, we have to just reverse the bits. Right, so I would assume that. Okay, so we're just reversing the bits. Let me grab out my book here. Let's grab the input. Grab this input right here. We'll grab this output. Guess we can leave a little note here that we are reversing, right? So I guess we can. My buddy's calling me. Text my buddy, bro. Okay. Sorry, I had to deal with someone calling me here, but anyway, okay. So reversing the bits here. Let's say if we can work with like let's work with like 11 or something, right? 11 would be 1 1 0 1, right? So why is the opacity like? So weird, dude. Anyway, okay. You know, to reverse this, what we'd be looking at 1 0 1 0 1 1. But how can we do that? What are some of the techniques that I learned yesterday to do that? Let me take a look at my. Trying to think here. So to find a single number, we use the XOR number of ones. So maybe we can we what, %2 and then right shift? I think maybe that might work. Let's see. 2. Hey, hello. How old are you? I just turned 24, dude. So, Unk status, dude. Nah, I'm joking. Yeah, I'm young, but kind of looking to land my first entry level role. But yeah. How are you today, Daniel? You goated, bro? So I'm thinking modulus 2, right, to get the last number if it's 1 or 0, right? So modulus 2 will either get if it's 1 or 0, but then we can somehow, I feel like maybe use some sort of bit shift or something. How old are you? Okay. So I think what we're going to do here is we're going to create a result, right? So we're working with a 3, 4, 5, 6. Did it say 32 bits, right? 32 bits unsigned integer, right? So int is 32 bits, right? Because it's 4 bytes, 32 bits. So I believe we can just use an int, I think, but I'm gonna uint uint 32. Sub, what's up, Llama? How you doing, bro? Doing some result. I guess is equal to 0, right? We can use a for loop here, right? And we go int I is equal to 0, I is less than. How are you today, Llama dude? It's good to see you, bro. I is less than the n dot size. Then we can go I plus plus. Good, thanks for the live, man. Thanks, man. You really enjoy the lives, dude. I really appreciate that you come every day and come hang out. It's pretty cool sometimes that I have kind of. And Not Sure's here, dude. Not sure how you guys doing. I appreciate both of you coming around and checking out the live all the time, dude. I really appreciate it. It's actually kind of cool that you guys always come back. But what does it mean by reverse the bits? So pretty much what we're doing here. This helps me a lot and made me motivated. Oh, okay. Sweet, dude. Well, I'm happy that I motivated you, dude. So pretty much what it means by like reverse the bits here, bro, is I'm using an example here. So I'm using 11, right? So this is in bits, you know, this represents 11, right? So pretty much we're just reversing this, right? So 1101, 1101, right? I mean, this is the reverse, right? We're just reversing it. And the way I'm thinking about doing this, right, is, so if we get the number that we have, so we're working with 11, right? If we do the modulus of 2, right, this would be equal to 1, right? So then we know what our first bit is. Our first bit is 1, right? So that means we can add that currently. I have a result, right? We can add that to our result, right? So result is this, right? Then, from what I know, is that we want to use some sort of shift operator, right? So, and I'm not really familiar, either a left shift or a right shift. I guess this takes a lot of thinking for me. a right shift. So this is a right shift, and this is a left shift, right? And I believe we would left shift here. I believe. And I ran out of water, dude. I gotta grab another water bottle. 1 second. Gotta grab that water bottle, baby. That's all confusing to me. I would have thought the reverse of 1011 is 0100. No, it's not. Let me think here. What do you want to? So no, like, I don't know. Maybe I can kind of explain it here, right? So this is represented as 11, right? Right. That's the base case here. This is 11 in binary, right? So we want to reverse this, right? So if we were to reverse this, we have 1011, right? If we would want to reverse this, right? Okay. We would move this 1 to the front, right? So 1 here. Move this 0 here. 0. 1 goes here. And then our last one goes over here, right? So we get 1101. Right. Does that make sense? We're just reversing the form in binary. If that makes sense. I hope that maybe was a little bit better of an explanation. I don't know. I'm not a teacher or anything, but so okay. I think it does, yeah. Okay. Sweet, bro. Sweet. So I believe we want to do n size here. We would do 32, right? Because we want to loop through 32 bits, right? Because we're working with a 32-bit integer, right? Unsigned integer, right? That means everything's positive if it's unsigned. So now I'm thinking here, right? So how would we do this? I'm trying to think. Do we take the n here? n%2 is 1. Right? But that... I'm not sure. Trying to think here, guys. Last bit is equal to n%2, right? So we grab our last bit. Now what we want to do? I feel like somehow we're going to have to maybe left... See, I don't know what to do here. Like, I feel like we're working just with n here, right? But really here, I mean, we're looping with this for loop 32 times, so we're going through each bit individually, right? right? And we will want to go n divided by equal to 2 every single time, right? Because then that's going to drop it by 1 bit every time. N divided by 2, we're right shifting, right? Let's confirm that is that right shifting? Discards the last bit. So divides by 2, right? I feel like we're gonna have a couple more lines in between here, right? To left shift would be times, right? It would be the opposite, right? So maybe we could do result is equal to result times 2 plus our last bit. So let's like let's print our result here. Whoops, I forgot some braces here. Right, so okay. Let's print our result here. See what we get here. I think I'm missing the colon here. Missing a colon here as well. There's another colon there, bro. Missing colons everywhere. We need to return something. Return our result. Oh, wow. Okay. Well, that worked. Wow. I cannot believe that worked. Okay. 0, 0, right? We add to 1. We go to 3, right? So we're doubling it every time. Times 2, which is... We're gonna... there's probably a more bit manipulation way to do this, but the way I'm thinking, this gets our last digit, right? Last digit. Then this bit shifts left, right? Bit shifts left. And then bit shifts right. Right? So we're doubling our result every time. 0, 0, 1. 1 times 2 is 1 again. Zero, 0, 1, 3, 7. Ow. Doubling our result. We're investing. Result times equals to 2. Trying to get an example here, because I like visualization in my head. So we have n is equal to 5. That's what we want to change. Our result is 0. right? Our last bit, right, is 1. So we grab our last bit, right? We bit shift left, right? But we're timesing it, but it's the same thing as bit shifting to the left. Result times 2 plus last digit is 1. And then dividing it by 2, we're bit shifting right to make this smaller every single time. And %2 is 0, right? So we're looking at a 0 value now, right? So dividing it by 2, we get what is 3 in binary, right? So 3 in binary would be, oh no, I think it would be 2, right? It would be 0. It would be 0, 1, 0, right? So then when we get this last bit here, it would be 0 this time. Now we're looking at 1 times 2, which is 2 plus 0, right? Is 0. And then we divide by 2. Now our n is 1 again, right? So then we go back to here, right? So we're bit shifting right every time, right? And we're doing the same thing here for our result here, right? So this is our result here, right? Every time. So we start at 5, which is 101, right? Okay, we're bit shifting left every time, right? So then we're going 1, 0, right? And then we're going 0, 1, right? But for our n, right, we're starting off at 1, 0, 1. Wait, sorry, no, this is our n, sorry. My bad. This is our n, right? Where we are bit shifting right. Bit shifting right. Right? And then this is our result, right? Where our result is 0, right? So it's 0, 0, 0. Okay. Then we 0. Then what are we doing here? We're doing result is equal to times 2 plus 1. So 0 times 2 plus 1. Then we're going 0, 0, 1. Then we're going result times 2. So we're 1. 1 times 2 plus 1 is 2. So what is it? 0, 1, 0. Bit shifting left. Then we are shit. And divide by result times 2. 2 times 2 plus 1, which would be 5 plus 1. So then we'll be shifting again like this. I think would be 5, and that's why we return 101. Yo, what's up, bro? Matthew Sogun, nice to meet you. Nice to... Oh, actually, you were here yesterday, bro. Appreciate you stopping by again. Going through some bit manipulation problems again. Trying to do it the right way. So I guess this works, right? What kind of jobs are you targeting? I'm not specifically targeting like big tech or anything like that, but I'm how's your Leetcodin going? It's going good, dude. I'm just looking for an entry level role, bro. Honestly, I don't have any like specialization or anything. I just love programming, and you know, I work on some projects, done some web development projects. Currently doing a game project in C++, so you know, just currently, you know, just kind of done a bunch of things. So yeah, done a few internships and everything. So just trying to land an entry level opportunity. That's kind of what I'm aiming for. So nothing in particular there, but yeah. Leetcodin's going good though, dude. Doing some bit manipulation, trying to build my knowledge from the ground up. Are you doing software engineering or are you like web development? I'm new to this computer science stuff, so I'm super interested. All you need to know for East is V is equal to IR. There you go. Am I doing software engineering or are you like doing web development? I don't know, dude. I don't really have a preference. Again, I just aiming for an entry-level opportunity, if that's in web development or that's in software engineering or that's in, you know, whatever it is. Like, I have tomorrow a preliminary interview for this one. Nice, bro. I'm just aiming for anything for an entry-level role, dude. So that's the goal. Hang on, my mom's texting me. 1 second. You got this, bro. I believe in you, man. Thank you, dude. Yeah, the support's been crazy, bro. I think I mentioned this on one of the other streams the other day, but like, I was doing this series, man, and there was like, I think for the first 140 episodes or so, I had like maybe 2 views a video. And then one day, randomly, bro, one of my videos got like 100 views, dude. And then like, the difficult part of C++ is that is not that common to practice in a real independent project. Yeah, I'm building a game right now in C++ using SDL3. So just trying to get my lower level programming skills up. Yeah, man, just kind of working at it every day. I'm looking for a job for January, so I'm aiming to start a role in January because I'm graduating here in December. So, but yeah, it's been a crazy journey though, Matthew. It's been crazy to see where we came from. I mean, this channel nearly has 100, I think it has like 650 subscribers, which is like insane to think about. So yeah, like what I said, like the first 150 episodes, I don't even think maybe I gained maybe 5 subscribers, and it probably was my friends, in the first 150 episodes, and then just like one of my videos just like got a shit ton of views randomly, and then it only went up from there. So it's been kind of crazy. So it's been insane, dude. But yeah, it's been a crazy journey. So hopefully we'll be landing something here for a January start date. So I know that would be great. So that's the goal. Just trying to work at it, and yeah. Ever plan on showcasing the games code you're working on? Yeah, I am. Honestly, I haven't really done a lot. I mean, I can show it right now, dude. Honestly, I didn't work on it today yet. I plan on working on it after the stream, but shit, Visual Studio. Yeah, this is all I got so far, bro. Honestly, this literally you'd be like, oh, really, this is it. Like right now, so I'm building the 2D top-down platformer. So literally right now, all I have right now is just the functionality to place entities on the screen. I mean, which is like the foundation of the game. You know, I plan on building the 2D balloon shooter. You know, like the game on the phone where like you place the towers and they like shoot the monkeys or whatever, or the balloon. Sorry, the balloon. You shoot the balloons. The balloon tower defense. I think that's what it's called. I'm trying to build like a replica of that. So you know, adding the functionality of adding each entity onto the screen. I plan on having about, I think, 4 or 5 different things to add. So you know, having the hotkey 1, 2, 3, 4, and 5 that places different entities, getting that working, and then you know, probably getting, you know, that's the functionality I want to implement today, is adding the different rectangles, colored rectangles or entities, I guess. And then probably maybe tomorrow adding the functionality that, you know, the new entities that come out can come on the screen. I don't know. I'm taking it day by day. Very, like, this took me a long time to implement, bro. This like This literally looks so simple, but this took me like, I don't know, probably like 7-8 hours, maybe 6-7 hours to get to this point. So maybe even longer than that, to be honest, dude. Like, but yeah, it works. So happy about that. But yeah, this is what I got so far. Not much, but getting there. So that's what I'm working on. I plan on streaming this, doing this on stream, like working on it on stream. And I've kept saying that. I said I was gonna do it this weekend, or last weekend. Anything with OpenGL, SDL takes forever first go around. Yeah, I mean, yeah, it's tough, bro. It's tough. My object-oriented programming is like needs to get better, so I think that's why it takes me a long time too. But it's hard for me to think about, and I'm a slow thinker too, so it's hard for me to think about. But yeah, I mean, we're making progress, so I plan to keep making progress. I'm working on a web development project too in React. Rate My Frat. I was in a fraternity in college, so working on this thing called Rate My Frat. So I'm working on this too. I did a little bit. I added the search functionality yesterday in the search bar, so kind of doing all sorts of different projects, working on this as well. But yeah, maybe I can show off it's on my Linux boot, so this project here, I would show the code and everything, but it's on my Linux boot, so don't want to clone it and show it all and everything. It's just not worth it right now. Maybe when I stream it, maybe I plan on streaming this one day too, the development of this. I don't know. But yeah, I like to stream the Leetcode, and people ask me all the time, like, do you do projects? Like, yeah, of course I do projects and stuff, but to me, like, I like to stream the Leetcode just because it keeps me going. It keeps me consistent with the Leetcode. Like, I know it's not really probably as important, but I feel like an hour a day like can only help. So at least with my problem solving ability and the way I think about like data structures and algorithms and all that. But yeah, so that's why I like to stream the Leetcode, and it's simple too. Like, people can tag along, people can do the problem with me. People can help me on the problem. So just like it's easier for people to like kind of see that on stream, I feel like, in a way. So yeah, sorry, I kind of was a little bit of a rant, so my bad. Fair enough. Whatever keeps you going, man. Yeah, dude. Yeah. So yeah, that's really about it. So anyway, let's jump into doing this problem. So I want to take a look at the other way here to do this problem. So actually I believe we can keep this code here. So I believe there's a different way we can do this. Doing with the left shift and the right shift here. So if we were to take the result here, so we do int last bit is equal to what sort of projects are you working on? Not sure. You work on anything interesting? We get our last bit, so n%2, right? What can we do here? Can we do like result is equal to result left shift by 1 plus 1 and then n right shift by 1 return result. Oh my gosh, dude, I always forget the colons. C++, man. That's what you get from going through all sorts of different languages and shit. Like maybe masking and rotating. Yeah. I'll put a 0. So the thing is, at series design, is that I'm not familiar with specifically what masking is yet. I'm still extremely new to these sorts of problems, so let me search it up. What is masking in bit manipulation? Set specific bits clear. Toggle a bit. Set a bit. Oh, dude, there's so much to do in bit manipulation, dude. There's so much to think about, man. So what if we did result is equal to result plus 1? Ah, shit, dude. Oh, wait, no, it wouldn't be last bit. It would be result fuck, dude, I don't know how to do this. Result plus or equal to the last bit? Would that work? Oh my gosh, dude. Forget the fucking colon every time, bro. There we go. Does that work? There we go, that works. Okay. So we grab the first value, right? Again, this is the same thing, but instead we're kind of actually doing it. Instead of working with the specific integer, which is really slow. So we grab our least significant bit, right? Then we bit shift by 1 left, right, for our result. Bit shift left. Add our last val. And then what we bit shift right. I gotta write this down, dude. Because I fucking small peanut brain like me, dude. Needs to write my shit down. Helps you kind of remember the problems too, especially these earlier ones, the way I kind of thought about it and the way I solved it. Expand, but using Windows, yeah. I dual boot. My mint's on my other drive. The reason why I'm on this Windows drive is because I'm working on C++ and projects here. So I like to use Visual Studio 2022. Wilding. I don't know what that means, HoloLight, but Linux yeah, bro. Yeah, it's on the other drive, dude. I dual boot. This is my Windows partition, so just to work with Visual Studio. I love Visual Studio because it has the debugger and everything, so yeah, type shit. Linux equals GOAT. Yeah, bro. Linux is goated. I'm not a Linux Chad though, dude. Okay, so let's think about this, right? We take 190 reverse bits. Right, we take went through 32 times, you grab the last bit, right? Then we bit shift left. Results. Equal to 1. Result plus or equal to last bit. And then we do bit shift right. Will you HoloLight, what sort of Linux distribution you use? Will you make a vid on this when you're done? Sorry, if what do you mean make a vid on this? I usually make recap videos on my channel. So yeah, I mean I make like a 1-minute video after, but that's really about it. If that's what you're asking. Bit shift left. Sorry guys, I'm just writing this shit down. Add our last val. And then we bit shift right. Yeah, like a recap. Yeah. Yeah, I do. Yeah, I just recap the problems that I do. But yeah, let's take a look at, I'm just doing Leetcodin's bit manipulation one really quick. So we did this one too. Sum of 2 integers. Let's take a look at that. We can also take a look at our daily problem. I think it just reset. Longest subroutine maximum bitwise and. Same thing. Sum of 2 integers. So this one's probably going to be a little bit tougher. So given 2 integers A and B, return the sum of 2 integers without using plus and minus. Max, how many Leetcodin problems have you solved till date? Dude, probably a lot actually. I've solved about nearly 500. Yeah, 468. Solved about 468. So it's been a little while, dude. This is from all the videos too, bro, that I have on my channel. Like, I think when I started the series, it was like, this is the day I started. I think it was November 4th, or maybe it was November 6th. One of these days, but I practiced for a little bit before doing my own, but I wanted to stay consistent with it, so yeah. Wow. Yeah, it's a lot of problems. Yeah, so I've been pretty consistent with it. I mean, you can see, like, I just try and do a couple problems a day, like, you know, only about an hour, maybe an hour and a half, so yeah, it's a decent amount. But I did skip over bit manipulation. I don't have a lot of experience, so don't think I'm like goated at Leetcodin, because I'm not, but like, you know, I'm trying to learn bit manipulation problems because I kind of skipped over them a little bit because I just hated them and I didn't really want to bother learning them, so goodbye. YouTube recommended me to you, so I checked you out. See you later, HoloLight. Thanks for stopping by, bro. It's definitely good. Yeah. But yeah, my favorite problems are graph problems, believe it or not. And I feel like most people like hate those problems. I like graph problems are my favorite ones to solve. I just feel like they're so straightforward for me to think about them. They're like so. BFS is my favorite algorithm, and my favorite problems are graph problems. I also like binary tree problems too. They're also good as well. I feel like they're all pretty similar. I mean, it's only really BFS, DFS, and just identifying those, and then the graph problems are. I enjoy doing those too. So. Yeah. Okay, so we're given A and B here, right? So let's think about this. So we can pull this on our screen. Given 2 integers A and B, return the sum of 2 integers without using plus and minus, right? So we're given A and B, right? So one being, I guess we can draw the binary here. would be 1. 1 here would be 0, 0, 1, right? And then we have 0, 1, 0. This is possible, but what in the hell is this question? Yeah, dude, I don't know. I don't know. Bit manipulation question, dude. I used a plus or equal operator. I've kind of like, to be honest, dude, I suck at these bit manipulation problems, but I've kind of really enjoyed thinking about them because they're definitely interesting. I see kids before entering college clicking on 1,000 problems on Leetcode. How are they solving so fast just after completing high school? Honestly, dude, they've probably been fucking programming their whole life, dude. Not gonna lie, but yeah, dude, there's just some cracked people out there. I don't know, dude. They just know everything. It's insane. But yeah. So let's think about this. How can we... Let me grab my notes out here from the past bit manipulation problems we've done. This is why it's good taking notes, man. Taking notes is very very good. I feel like it helps with your memory too. So adding bits. So sum of two integers. Given two integers, A and B, return the sum of the two integers without using plus and minus. So we have to deal with negative numbers too. That's going to be tough. I feel like I could solve this using positive integers, but now we're thinking about negative integers, so that is going to be really interesting. Obviously here to add these two, right? If we were to think about adding them, right? I mean, 1, 1, 0, right? 1, 1, 0, then 0, right? I mean, that's 3, right? You can refer to Take You Forward YouTube channel in case you get stuck. Yeah, I do look at YouTube all the time. In the beginning, I was looking at a lot of YouTube. Right, so I feel like we can implement the addition right here of a positive number, right? But if we were to implement what a negative number would be, right? I feel like this is the tough part of the problem dealing with the negative case here. It's pretty simple to add the numbers, but are they different? Adding negative number behaves differently than adding positive numbers at the binary level. So two's complement. Adding negative number works the same logically. Internally, negative numbers are represented using two's complement. You don't need to do anything special. I learned about two's complement in college, dude, but I have to get a refresher on it because I don't remember off the top of my head. It's been a while. I'm gonna ask GPT to give me a rundown of two's complement again because it's been a while. Give me a quick rundown on two's complement. Two's complement to represent negative numbers binary, positive negative values. Same as regular binary, right? Invert all one's complement. Add 1 to the result. Invert all bits, right? Okay. Add 1 to the result. 1, 0, 1, add 1. This is negative 5. Okay. In electronic XOR is used to sum in binary. Okay. Appreciate that, series design. Trying to think here. Maybe... I mean, I don't know. I feel like if we really wanted to think about this problem, we could have some sort of like helper function, right? That could deal with like positives, right? But that's, I don't feel like that's right. You know, we need to think of a way that can deal with both, but I'm not sure off the top of my head, to be completely honest with you. Maybe did they have hints here? XOR AB. Yes, XOR will be used. Yeah. So yeah, you guys are right. Yeah, XOR here adds carry A and B. Bit shift left. If anyone asked me this in an interview, I wouldn't be willing to work with him or her. No matter how many times I look at the solution, I have to relearn this problem every time I see it. Must be a tough problem then, dude. A moment of silence for those who didn't solve it beforehand and got it in the interview. Moment of silence. I think I'm gonna watch a video on this, to be honest. You know, I haven't solved this before. Obviously, I skipped over it. I mean, I haven't really looked at it before, so I think this is probably a good time to watch a video. So let's take a look at a video. Hopefully, it shouldn't be too long. Leetcodin here has an 11-minute video. This may in Java. I guess that's fine.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve sum of two integers, and finally this is actually the last blind 75 question that we have to do on this channel. We've been tracking all the blind 75 problems on this spreadsheet. Link will be in the description if you want to take a look. I've actually finished all the questions, even a couple of them that are blank. I've recorded those, and this sum of two integers is finally the last blind 75 question we have remaining. Okay, now let's get into the problem. So we're given two integers a and b, and we want to return the sum of these two integers, and the only catch is that we have to do this without using the plus and minus operators. And that's definitely going to make this tricky. And by the way, don't
got 3K dislikes, bro. That's crazy.
Pay attention to this dislike up above. So I'm sure you know how addition works. We have 1 plus 2 and the output is going to be 3. So if we can't use plus and minus, we have to get creative, and by creative we mean bit manipulation. So when we look at the integer 1, it's going to look like this in binary representation. The integer 2 is going to look like this. So we know, of course, if we add these, right, we can do it digit by digit. This is going to be 1. This is also going to be 1, and this is the binary representation for 3. So that works, but of course we have to do it without doing the plus operation. So we're going to have to do some kind of bit manipulation operation on each of these bits. So let's think about this. If we had a 1 and we had a 0, we know that adding these two together is going to give us a 1 in the output. But we can't use addition. What kind of operation, logical operation, could we do on these two bits to figure out that the answer is 1? We know that this could be a 0 and this could be a 1, or this could be a 0 and this could be a 1, and adding these together still would be a 1 in the output. So if one of these digits is a 1, we will have a 1 in the output. But what would happen if both of these digits were a value that we're gonna, shift left and then add that carry to the remaining digits? And by the way, we could also have two zeros, and of course 0 added together would be 0. So what we really discovered is that if one of these is a 1 digit, only one of these is a 1 digit, then we'll have a 1 in the output. But if they're both 1s, then we'll have a 0 in the output, and if they're both 0s, then we'll also have a 0 in the output. So what we have discovered is actually a logical operator called XOR, or exclusive OR. It basically means only one of these two digits is 1, then you'll have a 1 in the output. If both of the digits are the same, then we'll have a 0 in the output. And that's exactly what we need in this problem. So XOR works. If we have two 1s here though, and we do the XOR operation, we're going to get a 0 in the output digit, which is exactly what we want. But we also want a 1 carry. How do we get that 1 carry? Well, you first have to ask yourself, in what case are we going to have a carry digit, right? When are we going to have this carry? Well, if we have 2 zeros, we're definitely not going to have a carry. If we have a single 0, then we're also not going to have a carry. But if we have 2 1s, this is the only case that we're going to have a carry. So how do we know if we have 2 1s? Well, we can use another logic operator called the AND operator. So if A and B are 1, then we know we'll have a 1 carry. But that 1 carry is not going to be added over here. That 1 carry is going to be in the left spot. It's going to be shifted to the left by 1. So actually, when we do this A and B operation, we want to take it and then shift it to the left by 1, and then take this new integer that we've discovered, right? And then take that and then add it here. So we're actually going to have a loop. We're going to do an XOR operation, and then if we have a carry value, we're going to actually take that new carry value and then add it again to whatever we have left remaining. Now let's try this idea that I just talked about on one of these examples, and what we're going to figure out is...
So I understand that, but I feel like, let me know if I'm wrong, but isn't a difference? I feel like adding a negative number, wouldn't that just fuck this up, or not really? I don't know. That's like my only concern here. I just think like
actually, when we're doing these logic operators, we don't have to do them one by one. We can do them on the entirety of A and B that we're given. Okay, so now let's take a look at an example. We want to add A, which is the integer 9. In binary representation, it looks like this. And we want to add B, which is 11. And this is what it looks like in binary representation. Well, we want to add them, but we know we can't use plus and minus. So what we're going to do is run the exclusive OR operation, which in code, I think it looks like this. We want to run the exclusive OR on these bit by bit, and we can do it on the entire integer A and B. If we exclusive OR them together, first this bit, well, they're both 1, so that's going to be a 0. In this case, one of them is a 1, so we're going to have a 1 in the output. 1, we have 2, but obviously 9 plus 11 is not 2. So we missed something. Basically, we didn't do the AND, right? In this case, we're going to have a carry 1 that's going to be over here, right? And we're also going to have a carry from these two, which is going to be over here. So
Kyle Sabrov, dude, I have a movie. Can I post the link? It's got coding elements, but it's special. I don't know, dude. I honestly, I don't really mind. I mean, if you can post a link, yeah, it's fine. But I don't think you can post a link in stream, so... I mean, I don't know. I have a Discord if you want to join that, but I don't know. There's not many people on there, but...
So what we want to do is take this new integer, which is going to look like this, and then add that with the result of A XOR B. Right? And, right, in this case, this is just the... we have a 0 in the output. But what integer is this? This is just the integer 2. But obviously 9 plus 11 is not 2. So we missed something. Basically, we didn't do the AND, right? In this case, we're going to have a carry 1 that's going to be over here, right? And we're also going to have a carry from these two, which is going to be over here. So what we want to do is take this new integer, which is going to look like this, and then add that with the result of A XOR B. The XOR does add these numbers, it just doesn't take care of the carry. So we have to take care of the carry ourselves, and when we...
Gabe A says just use ChatGPT. Yeah, I mean you can. Main character's name Max, movie the title Pi. Did that link post? I don't think so, bro. I don't think so, dude.
Basically take A logic AND with B. We also want to shift it to the left by 1, and then we'll get some other integer. So by the way, over here, we're going to take A and B and then shift it to the left by 1. So when we AND these two together, we get a 1. When we AND these two together, we get a 0. When we AND these two, we get a 0. When we AND these two, we get a 1. But we remember we want to take this and shift it to the left by 1. So what we're actually going to have is a 1 here, 0, 0, 1. Right, and then this place will just get filled with a 0. So now we want to take these two numbers.
I'm joking. You're doing the right thing. I'll sub up. Thanks, Gabe. Appreciate that, dude.
Numbers and add them together. And when we say add them together, we're going to do the same exact operations we did here. So we're going to first XOR these, exclusive ORing these, we get a 0, exclusive ORing these, we get a 0, exclusive OR these, we get 0, again 0. Here though, we do get a 1. So we got the exclusive OR, now we want to get the AND of them shifted to the left by 1. So and these two, nothing, and these two, we get a 1, and of course we want to shift it to the left by 1, which means we'll have a 1 over here. So I'll just put that 1 over here, because we know for the rest of these, this is not going to be ANDed, and this is not going to be ANDed, so this will basically be 0, 0, everything is 0 except this. So now we want to add these two together. Again, we're going to do our XOR operation first, XORing these, nothing. Here we get a 1. Nothing here. Here we get a 1. And when you AND these two together, we just get a 0 in the output, right? Logic ANDing these two will get us a 0, which basically means we don't have a carry in this case, which means we are finished adding them together, right? If we don't have a carry, that means we're...
Bro, that was an insane amount of Zors, dude. Like, he literally Zored it like 3 times, bro. Like...
done. So this is the result in that case. Now, what number is this?
Bro, what are these comments, dude? Man, like, that was so confusing.
When your kid is hurting and there's nothing you can do about it.
Just kept zoning it, dude.
Well, it's 16 plus 4, which is 20, which is exactly what we were looking for, right? Because we were adding 9 plus 11. So I hope that this makes sense, and I hope you kind of understand why it works. So now we can get into the code. And actually, what is going to be the time complexity of this solution? Well, it's going to be constant time, because first we're told that the integers a and b are going to be between negative 1,000 and positive 1,000. And how many times could we actually do this loop, before getting a carry that's, 0? It can't run forever. Like, of course, if these were arbitrarily large integers, then in that case, we might have like a linear time algorithm. But for the most part, this is constant time. And one more thing.
Dude, that was really interesting. Okay. What's the point of this question? Honestly, dude, there's no point of any of these questions on Leetcodin, to be completely honest with you. They're all just brain teasers. I sent the link in Discord. Sounds good, bro. Sounds good, bro. I'll take a look at the movie a little bit later. That's pretty cool, man. But yeah, let's think about this, right? So for A, add B. Yeah. I'm curious, like, what would be the condition for the while loop? I mean, there's some point to some of them, like getting ready for an interview, but this, nah, it ain't it. Yeah, dude. Alright, you can't add B. Yeah, I don't know. They're all just fun and games, bro.
I want to mention, I'm just going to use Java, even though I use Python pretty much exclusively on this channel. So now let's do our loop. And remember, the condition we're doing our loop is basically until the carry value ends up being 0. And B is what
till the carry value ends up being 0.
We're going to use for the carry in this case.
Okay, so B's our carry. I'm still not fully sure while B does not equal 0. Well, why is B our carry, bro? I'm not getting that part of this algorithm, dude.
Our loop is basically until the carry value ends up being 0, and B is what we're going to use for the carry in this case. And you'll see what I mean in a second. So what we want to do is we want to assign A equal to A XOR B, just like we kind of did in the drawing explanation. And we want to set B equal to A ANDed with B,
Left
and
shift,
then
right?
bit shifted
Yeah.
to the left by 1, and then we want to go to the next iteration of the loop.
Okay, so if we're working with 1 and 2, right? I kind of want to do this myself, right? If we're working with 1 and 2, okay, so we're working with so we're working with 1. So our A is 1, so that would be 0, 1, right? And our B would be 1, 0, right? So if we were to AND this, right? This would be what? 0, 0, right? Oh, this will only go for one iteration, I guess, right? This would be 0, 0. This would be the AND, logical AND. Sorry, guys. Man, I cannot. Anyway, this is AND. This is my shitty ass AND, but our XOR here would be, right, if we would have XOR this 0, 1, 1, 0, we would have XOR this. Oh, I think this would be 1, 1, right? Let me take a look at the XOR truth table again. Yeah, okay, I was right. Yeah, this would be 1, right? This would add these two. This would be 3, so that makes sense, right? So we're using B as our carry, we're using A as our add, or our XOR adding, right? So I guess we should probably go to a better example here, right? We have input A. Let's use a different input, right? So we have A, right, so if we're working with A, we would have A would be 1, 0, right? Represents 2. Then our 3 would be 1, 1, right? If we were to AND this, right? Jeez, that's not an AND. Shit, alright. This is my AND, my shitty ass AND again. If we were to AND this, right, we would get 0, 1, right? That would be our AND, and our XOR here, this would be our XOR, would be 1, 0, 1, 1. We OR this, we would get, or we XOR this, we would get 1, 0, right? And obviously that's not our answer here, right? So we have our carry here, right? We want to and bit shift by 1, right? And we bit shift by 1, we would go 1, 0, 0, right? So I'm trying to think here. So unsigned carry being what, A and B, and then we like bit shift left, right? This goes left, we bit shift left by 1. Full ladder? Yeah. I'm not sure, bro. I remember learning about that, bro, but I'd have to relook into a full ladder on remember learning about it, but it's been a while. Full ladder truth table. Yeah, I guess you're right. Yeah. With a carry, yeah. Shit. It's been a while, but yeah, you could be right. So we're given this. We're given 0, 1. A and B. Bit shift 1. Then we probably want to do like A is equal to A XOR B, right? And then we need to work with B too. So B being what, like A and B? I don't know. I have no idea. Let's think about this, right? So we have our carry, A and B bit shift by left, right? Which is this here. Right? Our A and B, right, is this here. And then our XOR is this right here, right? So if we were to go through that again, we would calculate our carry here, right? Which would be a second iteration, which should be here. The second iteration being, we have our carry here, which would be A and B. So shit, I'm confused myself now, dude. This is our A, this is AND, yeah. So A and B. So we have 1, 0 here, right? And our 0, 1 over here, our XOR. We would AND this, we would get 0, right? And then we bit shift it by 1, which would still give us 0, 0, right? So this would be 0 here. And then our AND would be 0. So if we were to XOR this, 1, 0, 0, 1, we would get XOR here would be 1, 1. And right, we keep going till B is equal to 0. So in this case here, B would be equal to 0. Right? Yeah, A and B, which is 0, right? So I think that's correct, right? Is 1, 1? Well, we're looking for 5, so shit, maybe not. This is 3. So fuck me. I don't think this is right. Yeah, I don't know, dude. I'm not sure. Let's see what he does
Loop,
here.
basically doing the same thing. And we learned that
he
these
does
two
B.
operations are
He does
equivalent to
1.
adding A and B together. But one little catch is that if we
Is this easy, medium, or hard? This is a medium problem, dude. It's got a shit ton of dislikes on it, though. I don't know where it was, but in the video, it's got like shit ton of dislikes. So it is a tough problem, I feel like, for sure. I mean, it's tough for me. I don't have a lot of experience in bit manipulation, so maybe for other people, no. But for me, yeah, this is a tough problem. Like,
already assign A to the exclusive OR, then when we try to assign B, we're using the new value of A when we actually want to use the old value of A. So before we reassign A, I'm just going to actually calculate a temporary integer, which is basically our AND condition, which is going to be A and B shifted to the left by 1. And then instead, I'm going to assign B equal to that temporary value to make sure that we use the original value of A, not the new value of A. And once we're done with that, eventually B will equal 0. B is the carry. And then we can go ahead and return the result, which is going to be stored in A. Okay, now let's run it to make sure.
okay, so we want to return A, right? So Let's see if this runs, dude. See what we get. So we're given 1 here. From my calculation, we got 0 here. My calculation, I calculated 3. So this, fuck, there's something up here. So what am I doing wrong here? I'm gonna go to the bathroom. I'm gonna take a break. I'll be back in 1 second. I'm gonna go to the bathroom. 1 second, guys. Okay, I'm back. Okay. Gotta figure out what we are doing wrong here. Okay. So we got our carry here. A and B with a bit shift left. A or B, B is equal to A and B. So I feel like that's the same thing he's doing here. Oh no, he's doing the bit shift left. The only thing different is that he's doing B is equal to carry. So that's my issue. Why does it have to be carry though? I'm not sure. So I guess let's think about it if it was carry, right? Let's go through our problem again. I'm going to redo the problem here and draw it on the screen. So we're given, this is our input. Right? A is equal to 2, B is equal to 3, right? We have our A being 2, so let's look at 1, 0. Then we look at 1, 1, 1, right? For starters, we can do our, our AND, right? Shit. Alright, my shitty ass AND. Don't mind it, but, wait, why do we have this here? This would be 1, 1. Whoops. How do we do an AND? I'm looking so hard for me. I'm trying to practice doing them. Oh, that's pretty good, dude. So we do our AND, right? We do the AND of this, right? The AND of this is 1, 0, 1, right? And then we want to bit shift by left, right? So if we bit shift by left by 1, this will come out as 1, 0, 0, right? Jake Jones, dude, what's up, bro? How you doing, man? Military man, dude. We bit shift left by 1, right? Then if we were to XOR these two together, right? And we had 1, 0, 1, 1, and we XOR them together, this would be 1, 0. So we get 1 here, right? So currently right now our A stored at 1, and our B is 100, right? Our carry, right? Then we do the same thing on our second iteration, right? And think about it, right? Our XOR is adding, and our AND is grabbing our carry, but I'm confused why we're left shifting by 1. So in our second iteration here, if we have A and B, so we did 0, 0, 0, 1, 1, 0, 0, right? We were to take the AND of this. Shit, that was a terrible AND that time, dude. Oh my god. Take the AND of this. Right, what is the AND of this, right? It's 0. Right? Then we would have bit shift this, right? It'd still be 0. Right, so this is our AND. This is with the bit shifted. Okay? Then we want to XOR this together, right? We XOR this, right? And our XOR would be what? 1, 0, 1. Okay. 1, 0, 1, we XOR. We'd make our carry. So A is equal to this, and then we'd make our carry equal to 0, right? Which is when we terminate our loop. And this is what? 5. Right? And we're looking for 5. Okay, so that works, right? We return A. Okay. Sweet. So to think about it right now, fundamentals is that A and B is we're looking for our carry. We're XORing together to add. We're going to make these notes here. So we write this down. 371, sum of 2 integers. I'm still confused why we are left shifting. And I think I'm going to ask GPT why I am left shifting, because that's the only thing I'm confused about here is exactly why we are left shifting. If someone in the chat knows why we are left shifting or could explain it, I'd appreciate it. But are we left shifting in 371 sum of 2 integers? Because what I assume if we don't left shift, it doesn't. In binary addition, when 2 bits add to 10, which is 2, the 1 is carried to the next higher bit. So we shift carry to where it needs to be applied to next. Oh, okay. Holy fuck, dude. Okay. That makes sense. So we're simulating the carry with the left shift. Okay. So A and B, right, gets us our... So adds, right? A and B adds. Okay, yeah, because A and B really, it only holds true if it's 1, 1. That gives us a 1, right? Which means we would then want to bit shift that to the left, right? To carry it, right? Because technically when you add 2 together, in normal addition, if you add 1 and 1 together, you'll get a 0, right? In normal binary addition. So if we carry it by 1, the left shift by 1 simulates the carry. So that makes sense. Then we XOR it, right, which normally adds it together, our A and our B. And then in our next iteration here, we'd AND it again. Okay, so this is making sense now, I think, for me. Apply the carry to the next bit. And we keep going till our B is 0. It is related to bit manipulation. Yes, sir. It is related to bit manipulation. That's why we're looking at this problem, right? So sum of 2 integers, right? So let's think about these notes, right? So XOR adds 2 integers together, but no adds 2 integers, no carry, right? Keep going, man. Thank you, Prabnor. Appreciate that, dude. Thank you. Appreciate it, man. So we add 2 integers, no carry, right? Our A would be, right? We do our carry. Our carry we calculate with A and B, right? Shit, dude, now I have to lock in, dude. A and B does our carry, right? Carry. Then left shift to simulate carry, right? Simulate our carry, and then we make B equal to our carry, right? So we keep simulating our carry until we get 0, right? And we keep XORing it and adding it. While B, so this is making sense. I think it's a little like, a little tough looking at it first time, right? I mean, it does click. I'm kind of understanding it, but it is like really interesting to learn about. A and B left shift by 1. Then A is equal to A XOR B. B is equal to carry. Alright. We return A. Okay, so that makes sense. I'm happy about that problem. That was a good problem. I'd recommend other people do that. That was really good. That really helped me kind of understand my knowledge about how to move that. So that was good. So I think tomorrow we'll look at reversing an integer. We did look at reversing bits, so I guess we can kind of think about it in a similar way. So this is helping me with kind of my, understanding of truth tables and all that. So anyway, I'm going to call it there. We've gone for about an hour, so I appreciate you guys watching. And I will see you guys all tomorrow. So thank you for tuning in. Thank you for all the nice comments and stopping by. So see you guys.